All right, so now we are on the top of page 4, and we're about to talk about the difference quotient, but I just remembered that I said something about the previous page. I said that I was going to come back to this part right here, and I forgot to do that. So let me talk about this last part really quick on the last example that we just finished. Before I found the domain of this example, I first computed what t over k of x was equal to right here, and then I simplified it, and it simplified to x minus 2. So say you were given this as a question. Say you were given this function right here, the x minus 2, and you were just asked to find the domain of this. What would your answer be? Well, you should ask yourself, do we have a denominator here? No. And then the other question is, do we have any even roots here? No. So for this, we would just say that the domain is everything from negative infinity to infinity, all real numbers. But look at what our answer was for this question. When we found the actual domain of t over k of x, we didn't get negative infinity to infinity, we got negative infinity up to infinity, but leave out the number negative 2. And so the reason why I want to point this out is to show you the importance of doing all these steps, especially this last step here. If we hadn't done this last step, we would have gotten the wrong answer. We would have gotten negative infinity to infinity. That's not what we want. Our domain needs to be this. We need to make sure that we're leaving this number out of that original denominator that we started with here. All right. Okay, so now let's go on to the top of page 4, the difference quotient. I already said that this is a very important topic in this course, and part of why that is because it's a very important concept in math. In a way, it's the basis of all calculus, because calculus is the study of change, and the difference quotient is an expression that computes the rate of change. So let's get into it. The difference quotient is a ratio, and the ratio is written like this. It's a fraction, so we have f of x plus h minus f of x all over h. That is called the difference quotient. This thing right here is the difference quotient, and it represents the average rate of change of a function. And say we have a function that when you graph it, it creates a straight line. If we graph a line, we know that there's a few different components to a line, like we have a slope and we have a y-intercept of a line. But to connect that with what we're talking about here, the slope of a line, that's the same thing as the average rate of change. So kind of a synonym for average rate of change is a slope. All right, so if you look at this difference quotient, it basically has 3 parts to it. The first part is right here, f of x plus h. The second part is this minus f of x. I'm just going to write f of x. And the third part is this h in the denominator. And when you're doing these difference quotient problems, it might be a little bit easier to think of these three parts separately before you put them all together into one piece, okay? So this example says find the difference quotient for the function f of x equals 5x plus 7. So what we're going to do is we see this phrase difference quotient. Let's write that down. That's what we circled up here. So that is f of x plus h minus f of x all over h. Now, I've written that down. However, remember when I said that there are three parts to it, this f of x plus h, and then this f of x, and this h, and we're going to kind of think of them separately at first. So the only thing I'm actually going to focus on to start with is the f of x plus h part. So start with, go off to the side, start with f of x plus h, and don't even worry about the rest of it. And if we break it down like this, piece by piece, it'll be easier to put the pieces together in the end. So first, just start by figuring out what this part is equal to. And sometimes when people see this, they kind of get freaked out. You guys actually already know what to do with this. And to show you that, I'm going to do a little side example real quick. Up at the top here, let's pretend that this is a totally different question. What if they were just asking you to find f of 4? If that was all they were asking you to do here, what would you do? How would you approach that problem? Well, we know that f of 4 means that you just take the number 4 and you plug it into this function, right? You would do f of 4 equals 5 times 4 plus 7. You're literally just replacing this x with the number 4. So now back to the one that we were working on. That's exactly what we're going to do here. So instead of replacing this x with the 4, we're going to just replace the x with x plus h instead. So I got 5, and instead of writing x here, we are replacing the x with whatever it says here. So we're replacing the x with x plus h. And then there's a plus 7 at the end. So I'm going to write plus 7 equals. And I'm just going to simplify this. Distribute that 5. So I'm going to get 5x plus 5h plus 7. All right, so that is our little prep work before we really get into this, and I really highly suggest that you do that off to the side before you get into the real work of this problem. A lot of times I see this all the time where people decide, no, I'm not going to do it that way, and then that messes it up. So just trust me on this. Now we're going to go back and look at what we have written here. The first thing it says is f of x plus h. Well, we just found what that is over here. We found that that is equal to 5x plus 5h plus 7. So that's what I'm going to write first. 5x plus 5h plus 7. So I've got that part done. What comes after this part? A minus sign. So I'm going to write minus. Now what comes next? It says f of x. But let's pause here for a second and remember something that I said on the very first page of these notes. Let me just go and scroll back there. Right here. I said that when we have a subtraction of two functions, you should put parentheses around the second function. So that's exactly what I'm going to do down here. I'm going to put parentheses, and then what does it say? It says f of x. What is f of x here? F of x is equal to 5x plus 7. So that's what I'm going to write. That's what I'm going to put inside these parentheses. 5x plus 7, and close it off, all over, and what's in the denominator? It says h. Okay, well, then I will write h down there. And that was really the hard part. The rest of it is now just simplifying. So equals, the first thing I'm going to do to simplify is distribute that minus across the parentheses. So 5x plus 5h plus 7 minus, distribute the minus to the 5x, and also distribute the minus to the 7. Don't forget that. All over h equals, and now we're simplifying even more. Let's look at this numerator. Some of these terms are kind of canceling each other out. So say this plus 7 is going to cancel with this minus 7. And then this 5x is going to cancel with this minus 5x. So all we're left with on top is 5h, and all we're left with on the bottom is h. And at this point, that means these h's cancel. We get just 5. And that is our answer there. So moral of the story is, if it says difference quotient, write this expression down, and then before you start working over here, go off to the side and only do the f of x plus h part. And all that means is you go to the function and you replace each x that you see in the function with x plus h, and then simplify that. Once you've done that, you plug that back here, subtract, and then in parentheses, you put what f of x is, and then the rest of the problem is just simplification. Okay? All right, let's do one more type of question, which is profit, revenue, and cost. So in economics, P of x typically denotes a profit function. R of x typically denotes a revenue function. And C of x typically denotes a cost function. All right, so far we're talking about profit in a business, or revenue in a business, or cost in a business. Let's think about that. I mean, we could think about all of these things in context of any type of business, but let's think about it in terms of like running a movie theater. So a movie theater gets revenue from people buying the movie tickets or buying the food and the drinks from the movie theater. So all the money that's coming in from the people who are going to the movie theater, that's called revenue. And then it also is going to cost money, though, to run the movie theater. So what you're going to hope is that the revenue that comes in from the people going to the movie theater is going to be more than how much it costs you to run the movie theater. Because if the revenue is more than the cost, then you're making a profit. So it makes sense in general that the profit is equal to whatever money is coming in, the revenue, minus the cost of running that business. So this is our profit function. And the reason why we're talking about this in this particular section is because look what's happening between these two functions here. We have a function for revenue, and we're subtracting the function for cost from that function. And that's one of the first things that we talked about doing on page 1. And we actually also did that right here. We did this function minus this function. And when we did that, we made sure to put the second function in parentheses. And that's also what we're going to do when we do an example of this down here. So this example says if r of x equals 200x minus x squared and c of x equals 5,000 plus 8x, find the profit function. Well, this is the profit function, so I'm going to write that down. P of x equals r of x minus c of x, and then I'm just going to substitute everything. R of x is 200x minus x squared minus, and remember to put the parentheses in when you're doing the subtraction. So parentheses, and c of x is 5,000 plus 8x. Close off the parentheses. And then the rest is just simplifying. So we got 200x minus x squared. And then because of the parentheses, we're distributing the minus across to the two terms inside there. So we're going to get minus 5,000 and then distribute the minus to this term as well, and we're going to get minus 8x. And then we look for like terms. We got 200x minus 8x. So that's going to be 192x. And then just personal preference, I like to put the terms with the higher degrees first. So I'm going to put minus x squared, and then the plus 192x, and then the minus 5,000. You don't absolutely have to do it in that order, but it is more commonly done like that in math, is putting your terms in decreasing exponential order. All right, so that concludes the Math 124 note outline for section 2.2.